Today we're here at Key Largo, Florida Keys, and I'm here to report on the coral reefs and what's been going on. The Coral Restoration Foundation is working to rebuild the damaged coral reefs. Let's hear from some of their members.
So my name is Derek Hagan. I am the Director of Education for the Coral Restoration Foundation.
Perfect. And what does it mean to be the Director of Education?
The Director of Education's job is through my team is to inspire others to take action in order to save our reefs using our work as an example. We do this through hands-on workshops, an internship program, volunteer program, dive programs where people can come out and restore the reefs hands-on, learning ecosystems where groups can come in and go online courses from other practitioners to learn our techniques. Pretty much we are wherever someone can be inspired to do our work, we are there.
First basic question. Why does coral need to be restored?
There's a lot of reasons why corals need to be restored. So the first one is that we are the ones who caused the issue. Our issue with the pollution in the ocean, we should be stewards of the things that we help destroy. Down in the Florida Reef Tract, we only have about 2% of corals left that were there in the 70s. So they're very much dying off. The corals are a habitat for small fish to live in. It also helps break up hurricanes when they come in. So hurricanes are worse without corals. So if we want to just be purely selfish, it helps protect people. If we're not actually
that's one of my questions. It's like, if people who don't even care, like, what can they care about?
Yeah, I think that's one of the biggest things is that, it actually does hurt people by not having it. And also all the fishing industry down the Keys, which is a huge part of the Keys, is the fishing industry and for food and stuff like that. Without the corals, the fish go away. So there's lots and lots of different reasons why too. It just depends on if you're asking, human centric or human caring about the world. You know what I mean? So
yeah.
There's lots. Yeah. Yes. So algae in the ocean does help connect photosynthetic, process and all that. One of the big things is though with the acidity in the ocean, it helps break down that coral. So the oceans get more acidic from just pollution and things like that. Corals become more brittle.
Heating.
Yeah.
How long has coral been around, and how quickly has human impact bleached the coral?
Pretty much, I had this rope where it was a long piece of string, and I had people stand on the rope. And I said, okay, now I want you to stand right here. And I said, this far on the rope. And I said, represents when saber-toothed tigers were around. And I said, now I want you to go down the farther rope. This is where T-Rexes were around. Now I want you to go even full down the rope. This is where sharks first appeared. Go farther down the rope. This is where the first land plants appeared. Keep going down all the way to the end. That is where corals are. Literally. So corals have been around forever,
it's like
ever,
bacteria.
Ever. Yeah, it's not quite that old, but definitely a long
around there. It's right after kind of.
Yeah, it's one of those. It's a very simple animal, similar to Porphyria, which is the sponges. Sponges and corals are those first kind of sentient animal, or not sentient, sessile animals living on the bottom of the reef.
So, since coral is so slow growing, and you are restoring it, do you have ways to speed up this process, and how long is it taking before you're able to outplant the coral that you're doing?
Great question. So yeah, coral is very slow moving, but our coral trees are kind of a solution for that. The coral trees are up in the water column. It allows us to lift them and lower them depending on the temperature. And also they have 360-degree access to nutrients, to sunlight, to all the things they need to grow. So we can grow a piece of coral from finger size to basketball size in 9 months. So honestly, we grow corals so fast, our biggest issue is getting enough people in the water to put the corals back on the reef. That's why we ask for our volunteers.
That's so funny.
Yep. So we have a solution. We just need the manpower to get all those corals back on the reef. The whole idea of this, the coral restoration in itself started because our founder was doing a 4-H project with his daughter. He owned a live rock farm in the Keys where, again, it's just underwater boulders and whatever grows on it, you can put on you can sell to the aquarium industry. Staghorn coral landed on there and started growing. Now, the thing is, it's an endangered species. So he was like, well, hold on, if this can
Yeah.
grow here, I wonder if we can make it grow faster. So his daughter actually designed a primitive version of the coral tree and
That's
started
so
growing the
cool.
corals. So it all started from a kid's 4-H project. We work with groups all across the world. We have a thing called the Coral Consortium, which is,
Cool.
I think, dozens and dozens and dozens of different coral practitioners around the world that we have brought together and we share ideas with. That's where our learning ecosystem is. And we're like, okay, well, here, why don't you try this? Why don't you try this? Let's about this. And we work with kind of a world group to try to find the best way to grow corals. Pages on our website, on the Coral Consortium. So we have white pages on our website where we have all that information where people can download them about the work that we've done, so they can easily get access to that. So we've done studies.
That's good.
So we have done studies on like where they grow the best. We've done studies on, the actual coral tree. One of our biggest technologies right now is our photo mosaics, which we literally have. We tried a drone, but right now what we found best is just a scuba diver swimming over top with a GoPro aiming down. Then we literally stitch all the photos together to get almost a 360 degree like model of the reef, and we can actually look at it for which corals are growing well, which corals are not, things like that. We're very big on just sharing everything we do because we feel like our goal is to be out of a job. Our goal is that the reefs are all perfect, that everything's doing well, and we've saved the reefs. It's an uphill battle, but
it really is.
But again, that's what we try to do. We really look at the genotypes of the corals we work with, and I think we have over 600 different genotypes in our nursery, and our goal is to make sure that we don't create a monocrop. A lot of times, a lot of groups, especially coral restoration groups, are trying to breed a super coral. So it's a coral that can withstand all temperature changes and does this and does that and does all this magical perfect coral. So we are actually against that, and the main reason why is because of, if you create a monocrop, it only takes one disease that is susceptible to it, and we lose every coral in the world.
That's so true.
We want biodiversity. And we found that this method has worked really well because during the heat wave that happened a few years ago, some coral nurseries down the Keys lost 100% of all their corals in their nursery. We had loss, but we kept over 50% of the corals survived because we had lots of biodiversity. Some did better in the hot water, some that didn't. Some did better versus disease, some don't. But again, letting them breed together and let them let actual nature decide. Because again, if we create this monocrop, we're gonna have to constantly guard it, change it, adapt it, and to us, creating this weird super coral is not the way to go.
No. And you do have that, it's called cryopreservation. How do you store and monitor those genotypes of the coral?
They're literally in a lab being preserved. I think we've done some with the Georgia Aquarium. We've done some with Healthy Aquatics Institute. We've done some at different places where we sent our genotypes. Our corals are so healthy; they spawn every year. They're literally they in our nursery. They act like they're actually on the reef, so they spawn and create babies.
Oh, that's great.
Lots of aquariums around the world come out and try to collect those babies so they can take them back to their places and help grow them and stuff like that. Which we're totally for, because one of the biggest issues with coral restoration right now is that the little planular larvae, the babies, when they get spawned, they have to find a clean place to land to grow into a full coral. The problem is, down in the reef, we're missing a bunch of our herbaceous fish, the big fish that eat off all the algae, so they can't land where there's a bunch of algae. So honestly, people coming and
where are the fish?
The big fish are all fished out. I think the biggest downfall at the start of the corals was actually a sea urchin disease that happened around the 70s and 80s that killed off all the sea urchins down in the Keys. A disease that killed off a bunch of the sea urchins, which the sea urchins were the ones that cleaned the reef the most. And without them, that's also the food of some of the bigger fish. So once you start losing some of these keystone species, things start tumbling.
So when you're out planting, you usually only use the staghorn, the elkhorn, and the ovacella.
Those are our main ones we outplant, but we have the capacity to outplant any of the corals we grow.
Yeah.
The outplant sites are across the whole Florida Keys. We have certain ones that we have this. I think there's 7 iconic reef sites that we're really trying to restore back. My favorite thing is it's a mission of hope. We actually have a solution. Here's what it is. You can actually get in a boat. You can actually put a coral on the reef. You can actually do this.
Cool.
So it's Alice Granger, and My title is Senior Director of Strategic Engagement at Coral Restoration Foundation. Our team regularly participate in international meetings and conferences where we're exchanging knowledge with other restoration groups from around the world. You know, we have methodologies that we've developed at CRF, but we know that restoration is not a one-size-fits-all approach. So, you know, it has to be community driven. You have to understand what is the value, the cultural value, the socioeconomic value of a coral reef, because those sorts of things inform the strategies. So at CRF, while we have methodologies that work very well in our local context, we're also aware that you know, it's not a cookie cutter approach. So our methodologies may work necessarily, they may not be the best strategies for other people. So we're constantly trying to sort of educate ourselves, learn, keep our finger on the pulse. Also in Florida, you know, it's been multiple decades of, we call it death by 1,000 cuts. Okay. So it's multiple decades of gradual degradation. So you've had overfishing, pollution, you've had disease events that have gradually sort of eroded the coral reef's capacity to be resilient, because people dive on completely dead reefs all the time and have no idea. Not just nurse sharks, but reef sharks like black tips, white tips, you know, the large grouper, the large predatory fish. You know, I think the statistic is, but please double check this. I think we've lost 90% of the predatory fish in the ocean, like the fish at the top of the trophic pyramid.
Yeah.
And that's really impactful because all the levels below them regulated. And so once you take out these keystone species, you get this sort of these trophic cascades and these trophic collapses. So it's very hard to say exactly what it was, but yeah, overfishing is definitely one component of reef loss in Florida. Since the 90s, and I've been diving all around the world. I've never seen reefs as sad as the reefs in Florida.
Wow.
Heartbreaking.
And why do you think that is?
It's this combination of pollution. There was no sewage system when the Keys were sort of flourishing. The sewage system, you know, that took
so the overrun water and the pH.
Yeah. Exactly. So you get disease events, white band disease, which killed a lot of the acroporids in the 90s, later identified to be related to a pathogen found in the human gut. This was research that was done by the National Marine Sanctuary. And then that, you know, the results from that actually motivated people to start putting in sewage treatment, which really with water quality issues, you know, but by that point, there was already a lot of damage, just direct impact, poor boating practices, people collecting curios. You know, it's a lot. I mean, in Miami, for example, at the moment, we still have thousands of tons of raw sewage being pumped straight out into the ocean every second. We've got huge agricultural runoff coming through down from Lake Okeechobee, through the Everglades, down into the bay, which then come out, you know, onto the reef. High eutrophication. We've got golf courses which are covered in pesticides and fertilizers. That kind of stuff. I mean, it is a cumulative effect in Florida of a massive amount of local stresses. Yes, the background stressor of climate change definitely is the biggest threat to coral reefs around the world. But in places that don't have the same amount of local pressure, those reefs have a much better chance adapting. But actually, the only thing that helps these ecosystems is ecosystem restoration and good management and responsible interaction. You know, these are not infinite resources. These are delicate life support systems.
Reporting live here in Key Largo, Florida. There's the ocean. Perfect.
Hey everybody!
500 million years, coral reefs have been living among us, in our oceans, protecting us from storm surge, working with the mangroves to create a biodiverse place to live for organisms in the ocean. so many things cannot survive without a coral reef. Did you know 70% of our oxygen comes from the ocean? Coral reefs. Coral reefs. Because of coral bleaching and what's happening with overfishing and bottom, like the nets on the bottom of the water, killing our coral reefs, we can see a mass extinction of our coral reefs along with us. Since the 1950s, we have lost over 50% of our coral reefs, and it cannot survive with the human impacts going on right now. The 2023 global bleaching event took out 80%. Took out too many coral reefs. I'm over it. Hello. Coral reefs protect us from high energy waves on the coast. Before a very strong wave from maybe a hurricane or a storm comes to disfigure the ocean wall or hit the mangroves, a healthy coral reef can dissipate 97% of that wave. That high energy wave can dissipate from a healthy coral reef, and we're losing them. I've had it. From pollution to overfishing. What do you think? What do you think's gonna happen? If we don't do something now, and let's say you only care about money, because you're a greedy person, well, coral reefs bring in 9.9 trillion annual revenue. Estimate, whatever it's called, globally. When we have a coral bleaching event, and that means warm water, sustained warm water, what's happening is that the acidification in the ocean water means that the coral cannot produce its calcium carbonate that provides the skeleton to the coral faster than the damage it's getting from the acidification of the ocean due to the warm waters. And you know what? That's not okay. It's not. And although that the coral reef is bringing in money when it comes to divers and snorkelers alike, I snorkeled today, what happens is that these divers and snorkelers can also cause damage. So you know what it's called? You look at the coral, you don't touch it. Don't touch the coral. Don't you dare. If I catch you touching the coral. Hey guys! The coral reef we visited today, that is a protected area. Protected. Alright, so I need you to understand something. Bottom trawling, out. Protecting coral reefs, in. Overfishing, out. Protecting the coral reefs, in. Hurting the coral reefs, damaging them with your little flipper, your little hand, out. Protecting the coral reefs, loving the coral reefs, letting them regrow, in.